The next set of descriptive statistics that we need to talk about is center and then variation. Center, fairly easy concept, stuff that you have already seen before: mean, median, mode, mid-range. Variation is going to be a little bit more difficult. We're going to talk about something called standard deviation. Calculation is pretty lengthy, but we'll break it down step by step so we can get through it. So like I said, first, measures of center. That's what we want to work on. So mean and median would be the first two we deal with. Fairly common measures of center, things you've dealt with before. When you hear the word mean, it's basically your typical average. In statistics, we don't use the word average. We usually say mean. Arithmetic mean, also a term we would use. But really, it's what you would typically think of as an average. So to calculate the mean, it's very simple. You just add all your data values up and divide by the total number. And that will give us this idea of the center of our data, okay? Now, center could be read a couple of different ways. I mean, you can think of center as falling directly in the middle, or center as being the most common value, or center to be the average value, all right? So center could have a bunch of different definitions. So that's why we're going to have different ways of measuring the center. Median is another one. Now, median takes the measure of center quite literally, and it says, let's find the value that's exactly in the middle of the data set. And so the key to doing that is to make sure your data is ordered, okay? Make sure your data is put in order, it's lowest to highest. So we saw that that can be convenient for a lot of things previously to this. Median we could think of as a good measure of center when you really want to think about the middle. The good thing about the median is it doesn't take extreme values, what we call outliers, really into consideration when you're looking at the median, where the mean does use that, mainly because the mean uses all your data values and the median just cares about what value falls in the middle of the data set. And how extreme the ends of the data set are doesn't really come into play. So there's not really one better or worse measure of center. It depends on what you're looking for. I would say mean is the most widely used measure of center that we're going to see in this course. Okay, so we need to get through a little bit of review of some notation, and then we'll get on to how to do these calculations with some examples. So first, we need just a brief idea of what sigma notation is. Sigma notation is a notation that tells you how to add a bunch of things together. Summation notation is also known as sigma notation. So let's say you have a bunch of things you want to add together. So A1, A2, A3, A4, these are terms of, say, a sequence. But they're just a bunch of terms, things that you want to add together. If we put this symbol right here, this is your sigma symbol, that tells us we're going to add a bunch of terms together. And what this is saying is we're going to add a bunch of A's together, A sub K, where K goes from 1 to, say, N. So if I let K equal 1, I would get A sub 1. If I let K equal 2, I would get A sub 2. If I let K equal 3, I get A sub 3, and so on, all the way up to I let K go all the way to that top value, which is N. So I get A sub N. And this symbol here tells me I'm going to add all those up. So mostly the idea here is when you see that symbol there, that means you're adding a bunch of terms together, okay? So then this brings us to the formula for mean. So first off, when it comes to mean, we're going to look at two different means. We're going to look at sample mean and we're going to look at a population mean. The symbol for a sample mean is this symbol right here, X with a little bar on top of it, which we call X bar, okay? If N represents the size of the sample, how many data values are in the sample, to calculate the sample mean, what we want to do is we want to add all our X's together. That stands for our data values, okay? So we're going to add all our data values together and then divide by the total number of values in our sample, okay? Which is your typical way you would calculate an average, right? Add everything up, divide by the total number. And that's all this is telling us to do. This right here is a symbol called a mu, okay? Mu is that symbol, and that will stand for the population mean. But we calculate it much the same way. We're going to add all our data values in our population, okay, and then divide by capital N, which would be the population size, the number of values in your population. So a couple of symbols here now you're going to have to get used to. We're going to see a lot. X bar, sample mean, mu, population mean, lowercase n, number of values in your sample, capital N, number of values in your population. Okay? But you calculate this mean simply by adding everything up in either your sample or your population and then dividing by its total number. So here's a very quick example here. Say this is our sample, okay? And I want to find the sample mean. So what I'm going to do is I'm going to have to add all those sample values together and then divide by the total number. Well, if you count them up, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we add them all up here and then divide by 11, that would give us a sample mean of 2.7. As far as rounding goes, the general rule we use for rounding in any calculation, unless it's one that has its own specific rule, is we would like to carry one more decimal place in our final answer than appears in our data set. So if you look at all these data values, they're all 0 decimal places. So this one you see has 1 decimal place. So pretty easy, but it should be no problem calculating a sample mean. To calculate the median, what we need to do is we need to essentially find the 50th percentile. We need to find the data value that falls directly in the middle. So there's a couple of ways you can do this. A simple way to do this is to, let's say, add all your data values, put all your data values in order. So let's say there are 5 data values here. Okay? It's pretty clear once they're in order, this is the middle value, and that would be your median. Now that's 5 data values. What if I had 6 data values? Well, the middle falls here. Okay? So technically there are 2 values in the middle. So what we're going to have to do is we're going to think about there's 2 different ways to do this when there's an even number of data values or an odd number of data values. When there's an odd number of data values, there is a specific data value that falls in the middle. When there's an odd number of data values, what you're basically going to have to do is average the 2 middle values to find the middle of those, and that would be your median. We could, again, use this 50th percentile concept here of, K is 50 over 100, N is just the number of values we have in our sample. And then we could just simplify that, because 50 over 100 is 1/2. We would get this, and just count that. But again, the problem comes in that if there's an even number of data values, we have to find the 2 middle values. This will tell us how far to count, but what you're going to see is that that's going to be a fractional value when we have an even number. So think about it. If n is 5, okay, we would get this formula to be 5 plus 1, which is 6, over 2 would give us 3. So that says we should have the 3rd data value over. So let's say there's 5 data values. So here's our data set. Okay, 5 values, 1, 2, 3. The 3rd value over, that's your median. All right, but if there were 6 data values, so if n was 6, and we plugged it into this formula, we would get 6 plus 1 is 7 divided by 2. We would get 7/2. Well, 7/2 is the same thing as 3.5. And that tells you, okay, well, I basically need to average the 3rd and the 4th value, because the 3.5 value is my median, right? When we had 6 data values here. So we need the 3rd and the 4th, and we average those together. So here's an example for calculating both the mean and the median. So it's about AIDS data for the number of months a patient will live after taking a new antibody drug. And so you see it goes from 3 at the lowest to 47 at the highest. And it's already put in order. We have to figure out how many data values we have. Okay, so we'll have to count that off. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So 40 values total. That's your n. That's going to be important. We're going to need that to find the mean and the median. So if we're going to find the mean, what we'll do is we'll add all our data values together, right? And add them all up, divide by 40, we get 23.6. That's pretty easy. If we use this calculation here, where n is 40, this would be 41 over 2. So that's going to give me 20.5. Okay, so 20.5 means I have to average the 20th and the 21st value. So right here is where the 20th and the 21st value would fall. And so I'm going to average 24 and 24, which would just give me 24 as my median. We usually use this capital N as a symbol for median. There's not really a standard symbol for median, but capital N is the one we see most often. And that goes for usually both the sample and the population. We don't usually have two symbols there. We don't use it that much. We're going to use the sample mean and the population mean much more. That's why we need two symbols for those. But again, pretty easy to calculate the mean and the median. Another measure of center that you're probably familiar with is the idea of mode. And mode just talks about values that occur most frequently, so repetition. And the value that occurs most often would be considered your mode. Well, there could be multiple values that occur multiple times at the same amount of times, in which case we can have a multimodal situation. You know, you could have 2 modes, 3 modes, 4 modes. So if you have 2 modes, we call it bimodal, 3 modes, trimodal, and after that we just call it multimodal. So if we look at 20 different exam scores for a statistics test, and I said find the mode. So here are the scores, okay? We want to find the mode of these. You see some values are repeated. 59 is repeated twice, 63 is repeated twice. You get a couple of 72s here. We got a couple of 84s, and clearly 72 appears the most, so the mode would be 72. Okay? But if, say, 84 occurred 5 times, which is how many times 72 also occurred, we could have 2 modes. And it would be both 72 and 84. But in this case, there's only one. The next thing I want to talk about is how we can bring together the concept of distribution, the shape of our data that we talked about last week, and now this new concept of center with mean, median, and mode, and see how they relate to one another. So one thing you see here is, here's a data set, okay? Doesn't matter what this data set represents, here's a data set. In that data set, the mode is the same as the median, is the same as the mean. In this case, they're all 7, okay? Also, this is the distribution of the data. This is the shape. If you were to make a histogram for this data set, this is what it would look like. And you see it has this bell-shaped picture. It's this symmetric bell-shaped picture. We call this normal. Bell-shaped is called a normal distribution. What happens in a normal distribution is that the mean, the median, and the mode, they all sit right in the direct middle, and they're all equal to each other. So that would be 7 right there in the middle. And the picture's symmetric, where this side and this side of the picture are equal pieces. So you think of this as a mirror right down the middle. That doesn't happen with every distribution, but that is something that happens more specifically with this bell-shaped distribution. So you see how mean, median, and mode and the distribution all relate together. Here we don't have a normal distribution, a bell-shaped distribution. Here we have what we call a skewed distribution, where all our data values are clumping up on one side, okay? And so you see this trailing off to the left, right? It's pulling to the left. So we call this a skewed to the left picture. This is the data set that's giving us that picture. When we refine the mean, the median, and the mode, you see the mean is the smallest, the median is the middle, and the mode is the biggest. So if the order of the mean, median, mode line up this way and your distribution is here, that's no coincidence. Skewed to left picture will have the mean, to be less than the median to be less than the mode. Okay, that's a typical relation between the mean, median, mode and the skewed to the left distribution, where it's clumped up on the right and trails off to the left. So here you see the opposite happening. We have what we call a skewed to the right picture. You see it trailing to the right, clumped on the left, but trailing to the right. So this is a skewed to the right picture. This is a data set that's giving us this particular distribution. And then if you look at the mean, the median, and the mode, 7.7 for the mean, 7.5 for the median, mode is 7. And you see what happens here is that it actually has the reverse order. The mean is the biggest, the median is the middle, and the mode is the smallest. And that will happen when you have this skewed to the right picture. So you can see there's a relationship between mean, median, mode, so measures of center, and these specific types of distribution. Now these are very specific distributions. Sometimes you have what's called an erratic distribution, where you just have a picture that kind of goes all over the place. In which case there really is no rhyme or reason as to how the mean, median, mode would line up in here. But if you have the normal, the skewed to the left or skewed to the right, you have this alignment of the mean, median, mode for each.